Good afternoon, everyone. Today we shall discuss on Science Chemistry Chapter 3 on the topic Atoms and Molecules. First, let me give you a brief introduction about atoms and molecules. Ancient Indian and Greek philosopher suggested that if we go on dividing matter, a stage will come when particles obtained cannot be further subdivided. So this particle which cannot be further subdivided was called as a Parmanu by Indian philosopher Maharishi Kanat. And this indivisible particle were called as atoms by the Greek philosopher Democritus. The meaning of atoms means indivisible. For example, now look at this picture. There are 8 atoms. These 8 atoms can be divided into 4 at first. So now here we divide into 4. Later on, this 4 can be subdivided into 2 and 2. Afterward, these 2 can be divided into 1. Now, this from 1 we cannot be subdivided. So this particle which cannot be further subdivided were called as atoms by the Greek philosopher Democritus, and it was called as a Parmanu by Indian philosopher Maharishi Kanat. Now look at the definition. What is atoms? Atoms is the smallest particle of an element which can take part in a chemical reaction or chemical changes. So the smallest particle which can take part in a chemical reaction or chemical changes is called as atom. But now let me tell you the difference between atoms and element. For example, now look at this picture. Here, let's say the red one represent the atoms, whereas the whole things represent the element. So it is, for example, it is just like a building. A building is made by combining several bricks. So this atom is like a bricks, and this element is like a building. We say we could join together many buildings, many bricks, and then we build up a building. The whole thing we call as a building. So the same thing, many atoms combine together and form a element. So here atom is like a bricks and element is like a building. Now come to the most important part of the chapter. First we shall study Dalton's atomic theory. That means Dalton, he explained how is atom according to him. So John Dalton put forward his theory, that is Dalton's atomic theory, in 1808. So point number 1, let's see, point wise. Matter consists of a very small particle which are indivisible. That means according to Dalton, all the matter consists of a very, very small particles. That means all the matters are built up by very small particles which cannot be subdivided. For example, look here. Like books, pen, chair, table, etc. Whatever matter is around us, all of them consist of a very, very small particle which are called as atoms. So what is matter? Matter means anything that occupies space, have mass, and can be felt by one or more of our senses. That means to call a substance as a matter, a substance should follow these 3 conditions. That means they should acquire all these 3 conditions. That is, they should occupy space, they should also contain some mass, and they can also be felt by one or more of our sense organs. So if they cannot be felt by our sense organs, even though they occupy space and mass, then they are not a matter. But matter should contain all these 3 conditions. For example, what are the things which does not belong to matter is magnetism, light, heat, temperature, etc. are not considered to be a matter. There is all house, building, bricks, pen, chair, whatever material is there, they are called as a matter. Next, point number 2 is atoms can neither be created nor destroyed. That means it is similar to the law of conservation of mass. According to law of conservation of mass, also it's same thing. Mass can neither be created nor destroyed. So I told you many examples inside the class that if something give birth on this earth or some once died on this earth, this universe does not get any energy, or gain any energy, or this universe does not lose any energy, because the energy present in this universe remain the same. When someone give birth, then the person eat the vegetables, animals get energy and they grew up. When they die, then the same amount of energy, whatever is present in him or her, will be give out in other form. So energy can neither be created nor destroyed. It is the same thing with the point number 2. And look at the point number 3. Atoms of different element have different mass and properties. Now for point number 3 example, just look at here. Let's say this is atoms of element. I already explained to you, this is an atoms and this is an element. The whole thing is the element. So the same thing, let us consider this as atoms of hydrogen and this as an atom of oxygen. So point number 3, it says that atoms of different elements are different from one another. That means the atoms present in hydrogen, let's say it is round, and then the atom present in hydrogen, oxygen, is like a box, like a square, let's say. So now atoms of different elements, this is the atoms of hydrogen and this is the atoms of oxygen. Atoms of different element are different from one another. That means the atom of two element will not be same. Atoms of particular element will be same, but then atoms of different element will not be same. Now look at point number 4. Atoms of one element are identical. So now once again, let us take with this example. Atom of one element are identical. That means this is the atoms of hydrogen. So all the atoms present in this hydrogen element will be same. That means they will have the same shape, same size, same properties. And atoms of oxygen, if we consider oxygen, then all the atoms present in this oxygen element will be all same. They'll have same mass, same weight, same size, same properties, and everything. And look at point number 5. When element combine to form compound, the atoms of this element unite in simple whole ratio to form compound. That means when the atoms of two elements are combining together with one another, then they will always unite in a simple whole ratio number to form a compound. The next topic is molecules. A molecule is defined as the smallest particle of an element or compound that is capable of an independent existence and shows all the properties of that substance. That means a molecule, what type of substance should we call as a molecule is that it should be the smallest particle. It may be the smallest particle of an element or maybe a compound, but that can exist themselves independently, and that should shows the properties of the particular substances. For example, like water, carbon dioxide, hydrogen, nitrogen, oxygen, etc. These hydrogen atoms combine together with oxygen and form together. This was the property of water. Carbon combine together with oxygen and form carbon dioxide. Shows the property of carbon dioxide. Hydrogen atoms combine with another hydrogen, forming H2. The same thing with nitrogen and oxygen, and this shows the property. So this type of substances we call as molecules. Molecules are of two types: molecules of an element and molecules of a compound. So now what is molecules of an element? The molecules which are formed by combining the atoms of same element. That means if a molecule is formed by combining the atom of same element, they are called as a molecule of an element. For example, look at this example. H atom, hydrogen atom combined with another hydrogen atom. That means this is the atom of same element. Both are the atoms of hydrogen, and now they form hydrogen gas. And this second example is oxygen atom combined with another oxygen atom. That means both are the atoms of the same element, that is oxygen, O and O. Then they form O2, oxygen gas. The same thing with the third example, that is nitrogen atoms combined together with another nitrogen atoms. That means both are the atoms of nitrogen, same element, and they form into this type of molecules are called as molecules of an element, and the second one is molecules of a compound. So the molecules which are formed by combining the atoms of different elements, they are called as molecule of a compound. That means look at here now. First here in molecule of element, atom of same element combined together. But here in molecule of a compound, atoms of different element. Here is atom of carbon, here is atom of oxygen. So atoms of different element combined together form a compound now called carbon dioxide. And here atoms of hydrogen combine with atoms of oxygen and form H2O. So this is also a combining between the atoms of different element. So this type of compound, molecules are called as molecule of an compound. The definition of atomic mass and other things, gram atomic mass, I'll give you in definition later on. But now first you should by heart these things. When scientists, they calculate the atomic mass of a different element and they give different number here. So this number is a must for you to by heart. So after you learn this mass number of the element, the question asks you calculate the atomic mass unit of water. So now look at here. If the question asks calculate the atomic mass unit of water, then you have to remember that the chemical formula of water is H2O. So atomic mass of here, this water is formed by combining two different atoms. One is hydrogen atom, another one is oxygen atom. So now atomic mass of hydrogen is equal to 1. Because we learn from above that hydrogen is equal to 1. And next is atomic mass of oxygen. Oxygen also given here as a 16. So now for how many atoms is there and how many different type of atoms is there, you write out the atomic mass for all of them. And then now the atomic mass of water. The water is chemical formula is H2O. So now equal to, first we shall calculate for H. Hydrogen atomic mass is 1. So 1 into. And then how many hydrogen is present here? 2. So 1 into 2 plus oxygen. Oxygen is in between two different atoms, we should use plus. So oxygen is 16. 16 into, how many oxygen is there? 1. There is no number, so it is, let's count as a 1. So 1. So now 1 equal to 2 plus 16, 1 equal to 16. So 2 plus 16 equal to 18U. So in this way we have to calculate the atomic mass. But in case if the question asks you gram, for example, if the question asks you gram, calculate the gram. Gram atomic mass of water or any other things, then you have to remember this mass number as I told you, and then you have to calculate. The same process we have to follow while calculating, but if the question asks you gram, the only difference is at last you give the unit G. That is the only difference between atomic mass and gram atomic mass. The question asks you to calculate for ammonia, for carbon dioxide or whatever things. First you have to remember the atomic mass as I give you, and then by following the rules we will calculate the same process. So if the question asks only atomic mass unit, you give till up to U. What if they ask you gram atomic mass? Then after the number just give G. That's the only difference between atomic mass and gram atomic mass. Only gram atomic mass means the atomic mass expressed in gram. That's the only different thing. Thank you. Then I'll give you some notes. You click it and then you bar